Can we estimate the practical specific energy for another Na-ion cell that is made with the Na3V2PO4 2F3 cathode and hard carbon anode, similar to what was previously mentioned? How do we do this estimation, and what is the basis for this calculation? How does the voltage of 3.5 V of the cell influence the specific energy? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? When considering the specific energy, why does the text indicate that it's 295 Wh/kg based on the electrode materials, and how do electrode materials affect the overall energy calculation? What does the 50% laboratory to commercial cell conversion efficiency mean, and why is it important in this context? How does this conversion efficiency affect the practical specific energy, and why is this value estimated to be about 150 Wh/kg? How does this compare to the estimated specific energy of the WSU/P&L cell, and why is this comparison made? What role does the research conducted by Alistor European play in understanding the real-world performance of Na-ion cells, and how does the performance of the 18650 cell they built with Na3V2PO4 2F3 cathode and hard carbon anode shed light on the practical outcomes? How does the actual performance of this 18,650 cell, which has a specific energy of only 75 Wh/kg, compare to the estimated value of 150 Wh/kg from the earlier estimation? What factors could explain why the real-world 18650 cell has only half the specific energy of the earlier lab-based estimate? How does the performance of this 18,650 cell, which also achieved 4,000 cycles at the 1C rate, compare to the theoretical expectations for Na-ion cells? And why is the cycle life an important metric for evaluating the practicality of these cells? What can we infer about the difference between theoretical and actual performance when considering the specific energy and cycle life of the 18650 cell, and what factors might influence the gap between the two? How do the electrode materials and cell design play a role in this discrepancy, and what role does the efficiency of conversion from laboratory cells to commercial cells have in influencing the outcomes observed in actual products? How does the overall performance of these cells, including the specific energy and cycle life, contribute to understanding the challenges and potential of Na-ion technology in practical applications? How realistic is it to expect a specific energy of 100 to 150 Wh/kg for fully developed Na-ion batteries, and what factors influence this range? Why are the reversible capacities and voltages of numerous cathode materials so important in determining the specific energy of Na-ion batteries, and how do they affect performance? What role does the specific capacity of the hard carbon anode, approximately 250 mAh per gram, play in achieving the specific energy range, and how does this compare to other anode materials used in Na-ion batteries?